All right, welcome to the first day of new instruction of the fourth quarter in online learning. I'm sure that gets you as excited as I am. But anyway, what will get you even more excited is the fact that we're now studying my favorite section, which is parallel and perpendicular lines. So again, I'd take a pause right now, jot down the introductory information here about them. I'll talk through it briefly here, but again, pause, make sure it's in your notebooks and organized, and then we'll start in with the first few types of problems in this section. So again, hopefully two terms you're pretty familiar with. We would have touched on it at this point about a month ago. But parallel lines, lines which never intersect. So a quick visual there. Also the symbol, which means parallel, looks kind of like I wrote 11, but it's just two lines straight up and down. That is the shorthand symbol for parallel. Perpendicular lines are lines which intersect at right angles. So you can see a little box here. If I have two lines on a graph, that means that they are intersecting at a 90-degree angle. And again, the symbol for that is that I have, it's kind of an upside-down T here, anyway. Now, the important thing here, and I'm going to add this to the notes, parallel lines, the key idea of this section, so think about what we reviewed last week, or before Easter break. Writing equations of lines all start with slope. And that's the important thing. Now, hopefully you can tell me, related to each other, these two lines have the same slope. So that's going to be important here. Okay, parallel lines have the same or equal slopes. Okay, so that's going to be a really important thing here. Parallel and perpendicular lines, the way I determine pairs, all based on the slopes. That's going to be the important part. So that one, maybe not too difficult to see. Visually, it makes sense. If they're going up at the same rate and will never cross, think of what I just said. Up at the same rate, same slope. Next one. The perpendicular one is a little trickier sometimes to remember. So parallel, pretty easy. Oh, they got to be the same. Perpendicular, their slopes must be opposite So opposite meaning sign, so one positive, one negative, and you can see that this line here clearly has a negative slope. This one has a negative slope. This one here has a positive slope. So they have opposite sign slopes and reciprocal. Okay. And those two things must be true. Now, a quick example of reciprocal here. The reciprocal of 2/3 is 3/2. And for those to be perpendicular, one of them would also have to be a negative, the other one positive. So anyway, the types of problems we're going to see here quickly are going to be, are lines parallel, perpendicular, or neither. Okay, so parallel, perpendicular, or neither. Now, as I just said, the whole way that we determine this is all strictly based on one key concept. It's all about the slope. If they have the same slopes, they're parallel. If they have reciprocal and opposite sign slopes, they're perpendicular. If neither of those things are true, well, those lines are nothing special in relation to one another anyway. So the first one here. This is a great game you can play in quarantine. Get your family together, parallel, perpendicular, neither. I've never lost a game yet. So, the equation of a line. Start off with a real easy one here, hopefully. Okay. So, are the equations y equals 2x minus 3 and y equals 2x plus 4, are those parallel lines, perpendicular lines, or neither? The answer is they are parallel. Hopefully you noticed right away. Or shorthand symbol. And again, the only thing I look at is the slope. That's all I care about. They both have a slope of 2. If they have equal slopes, they are parallel. Number 2. Y equals negative 2x plus 4 and y equals 2x plus 6. Okay, so think about that one for a second based on the rules. The answer to this one is neither. Now, I know you may be thinking, wait, one positive, one negative, why aren't they perpendicular? They are not reciprocals of one another. So yes, we get the opposite sign rule. However, they must also be reciprocals. The reciprocal of 2, think of it as a fraction. 2 over 1 would flip to 1/2. If the numbers are the same, that means they are not reciprocals of one another. So again, to be perpendicular, both parts must be true. Okay. Next. Number 3. Give it a second, see if my video doesn't lag. No luck with that today, though, so far. All right. Y is equal to 2/3 x plus 1 will be our first line. And then the other line will be 3x plus 2y equals 4. Okay. Now, before, it was a very quick determining step here. Hopefully you recognize I cannot say yet whether these lines are parallel, perpendicular, or neither until I get slope-intercept form here for the second line. First one's good to go. I know that the slope is 2/3. That's all I care about from that equation. So what I'm going to have to do here, I'm going to subtract 3x from both sides, and I get 2y equals negative 3x plus 4. Finally, I'm going to divide everything in the equation by 2, and now let's see what results here. I get y equals negative 3 over 2x plus 2. Now let's compare slopes. Alright, they're clearly not the same. One of them is negative, one of them is positive, so clearly they're not parallel. Last, what I look at here is, are they reciprocals of one another? Opposite signs, okay, I'm on my way to possibly perpendicular. If I take 2/3 and I flip it, its reciprocal, sure enough, is 3/2. Therefore, since both parts of that are met, I have lines that are perpendicular. Okay, so again, the key takeaway from this problem is that in order to determine slopes of lines, I have to see slope-intercept form. Okay, so again, example of each. Parallel lines, 2 identical slopes. Neither, well, any 2 slopes that just randomly thrown up there. Perpendicular lines must have opposite sign slopes, as these did, one positive, one negative, and also they must have reciprocal slopes combined with that idea. So in this case, the 2/3 flipped to 3/2. So again, intro, parallel and perpendicular lines, and there will be an assignment that goes along with this concept this week.